The total surface area of a cube is changing at a rate of 12 square inches per second when the length of one of its sides is 10 inches. At what rate is the volume of the cube changing at that time? Okay, I'm going to give you a few minutes to do as much of this problem as you can, right? You don't necessarily have to solve the whole thing, but try to do as many of the steps as you can. So let me put up the timer first. So let's get over here. So let's see, what's a good goal? So these are our steps. Let's try to get at least up to the point steps 1 and 2. That's a good goal. And if you can do more than that, that's great. So steps 1 and 2, that's what we're looking for right now. And we'll do 3 minutes. All right. So also, I will say that this is a general strategy. There are some related rates problems that we will encounter in the worksheets and the recitation activities that don't necessarily follow these steps, one by one, especially if time is given to explicitly. Like some problems ask you, what is happening 3 seconds later? They actually give you a specific time. And sometimes that kind of changes the problem a little bit. So I just want to kind of stress that. Most problems can be solved using these steps, but not all of them. Okay, so what do we think for this? So what kind of diagram did you draw? Did you draw any at all, actually? Jake Wellen.
I
A
drew a
cube.
cube.
You drew a cube. Yeah, that's what I drew too. Drew a cube. All right, there's a square. Let me copy it. No. We copy it and we paste. this. All right, so we got a cube. What are the variables in our problem? What are the relevant variables in our problem? X. What's X, Justin? You can't just tell me X. X could be anything. X is what? X is the coordinates of the center, the X coordinate of the center of this cube. Okay, X is sides. X equals side of the cube. X equals the length of a side of a cube. Okay. Good. So X. Now, obviously, it's a cube, so all the lengths are the same. All right, now let's look at the given information. So what kind of information should I write down? So, okay, so let's see. Miriam said ds dt. What is S in this case? Can you explain what S is? Surface area. Okay, so ds dt equals 12. So S we're going to use for surface area. If you used A, whatever, doesn't matter what variable you used. And let's see, Jessica said when x equals 10. It's actually, you said it the opposite way. X equals 10 when dA dt equals 12. I mean, in terms of doing the problem, it doesn't really matter because you're going to substitute them later anyway. But I would say a more accurate description is ds dt equals 12 when x equals 10. But I don't think it really matters. Now, there's one piece of information that we're missing so far. Before we get to the actual equations that relate the variables, what are we looking for? dv dt. Good. Okay, so now obviously you guys have actually introduced more than just x. You've actually introduced these two variables s and v. So what are our equations? So what are the relations between our variables? V equals x cubed. And what about s? We need an equation that involves s. S equals 6a squared. Maya, I assume you meant a was the length of the side. Okay, good. Is there anything else that we need from this problem? I mean, just double check. The total surface area of the cube is changing at a rate of 12 square inches per second. That's taken care of by that first equation, ds dt equals 12. Good. Next, when the length of one of its sides is 10, that's the same thing as saying when x equals 10. Okay, good. Next, at what rate is the volume changing? That's dv dt equals question mark, you know? And then where do we actually get these two equations from? Well, that's from the whole problem saying that we're dealing with a cube. So this is just basic geometric formulas, right? Just you're expected to know the volume and surface area of a cube. Okay, what do we do now? So it's good to see a lot of people got that far. So what should we do now at this point? Should we wake up Adam, by the way? Should I do a poll on whether we should wake him up? You can't be wrong on that poll, right? Because I'll just do whatever the poll says. Okay, implicitly differentiate, good. Okay, so let's write some of these equations down. So I'm going to have equation 1, equation 2, and then I'm going to differentiate them to get equation 3 and equation 4. So my first equation is v equals x cubed, and my second equation is s equals 6x squared. So let's differentiate equation 1 to get equation 3. So what should I write down for equation 3? Three x squared? That's it? That's not even an equation. Y'all didn't even give me an equation. Okay, good. So I see some people giving me an equation now, right? I take this equation here, v equals x cubed, and I differentiate both sides. So on the left-hand side, I get dv dt, and when I differentiate x cubed, what do I get? I get 3x squared. That's just from normal power rule, right? But then chain rule tells us, okay, also multiply by dx dt. Okay, good. What about equation 2? So now when I differentiate equation 2, I'm going to get equation number 4. And so what should I get for equation number 4? Let's see, ds dt equals, I see a few people writing it. Miriam, Isha, Jacqueline, Hirsch, Sarah, very good. So 12x, that's normal power rule, and then times dx dt by chain rule. Okay, so now I have 4 equations. Good. Let's keep going. What do I do next? Sarah, can you tell me what do we do next? Was she expecting that? Uh-oh.
You plug in the values that you had before, so like x equals 10, and then the rate ds dt.
Okay, good. So ds dt equals 12, and x equals 10. And again, I'll keep emphasizing this. We always differentiate everything first before we substitute, right? Okay, so now we're going to get 4 new equations. 1 star, 2 star, 3 star, and 4 star. So what do we get? So let me actually write just to remind. I'm substituting x equals 10 and ds dt equals 12. So let's see what happens. So the first equation, I get v equals 1000, s equals 600. Those are probably not going to be very useful at all. Over here, I get dv dt equals 300 dx dt, and 12 equals 120 dx dt. Cool. And what am I after? I need to solve for dv dt. Solve for this. Notice how dx dt, so you probably noticed this when you were doing your work. You notice that dx dt was popping out because of chain rule. And you might have noticed, boy, I'm not giving any information about dx dt. It actually turns out it doesn't matter, right? Because when we get down to this step, we realize I need dv dt, so I need dx dt, but I can actually get dx dt from the other equation. So actually dx dt, you didn't need to be given dx dt. You can actually get that from the rest of the work, right? So don't be in a rush to think that you're not given enough information. Okay, so let's write down here. So first I solve for dx dt from 4 star. So from 4 star, we get that dx dt equals what? 1 over 10. So then from 3 star, we get dv dt equals 300 times 1 over 10. So we get 30. Now, what are the correct units, right? Because if you're pulled off off to the side of the road, right, and the officer says you don't know how fast you're going, officer, I was going 4. Right? He'll maybe give you a little laugh, and then he'll arrest you. So what are the units of this? Jacqueline says inches squared per second. Jessica says inches cubed per second. Oh, oops. Okay, we got an oops. So it's inches cubed per second. Yeah. Right. So it's a volume divided by time, right? dv. I mean, it tells you right here in this. Even though dv dt is not a fraction, it does tell you it's a limit of delta v over delta t, right? So a change in volume over a change in time. So volume is inches cubed and time is seconds. So inches cubed per second. Yeah.